once again a warm welcome back to the DrMBalmer channel. So, my plans for YouTube projects and videos and stuff sort of got out of phase with reality. Summer hit hard and we're already in end of June, I believe, yes. And I had plans for some other videos before this one, but since we're already in almost in July, I mean, this seemed like the more proper seasonal project thing to have a look at. Correct me if I'm wrong, but I sort of got that feeling. Anyway, today we're gonna look at this lantern. It's a plastic lantern from AliExpress. It looks pretty nice, actually. I believe it's ABS plastic. It has a huge solar cell at the very top, and it has a sort of pole mounting hole here in case you want to stick it onto some pole or some stick, I assume. It's got a plastic white thing in the middle going all the way from the top to the bottom, and it's basically a solar powered or solar charged lantern, and it comes with a detachable hook, so maybe you don't want this if you mount it onto a pole or something. But okay, you can leave this somewhere for now. Yes, so what is this thing? Well, I printed out some details just to make it easier. This is a solar flame lantern, outdoor waterproof flickering LED pendant light decoration for garden. And this is in Swedish kronor, so it's basically it cost base price was 177, which would equal to about 16 maybe US dollars equivalent. And then, as usual, when you buy something on AliExpress, you have to get some discounts, otherwise it's not worth it. And after the coins and coupons, I got it down to about $12, I suppose, equivalent US. And what does it say here? Well, we have some measurements in inches. I will also measure it myself in centimeters, but there you have the figures directly from the AliExpress item description. And from the same seller, the price is now 166 base price. So yeah, and it says it has a durable hook, and indeed I must say, yes, this hook is not made out of plastic, so it's metal. So that's fair enough. Built in 2200 milliamp hour high capacity battery. Well, I would very much like to test that, if possible. High quality ABS plastic, yes. High efficient solar panel, 20% conversion rate. That's pretty good for an AliExpress solar panel. Yeah, and there was square one and a round one. But the problem was that the round one, I didn't want it mainly because of the fact that the solar panel was larger on the square one, while the round one had a couple of square solar panels stuck onto it, but they didn't use all the available area. Alright, and also we can see that the rating was pretty good on this one, so 4.7 stars, 3 reviews, 22 sold when I bought it. And I have found similar listings and they all seem to confirm about the same thing. Pretty high rated for its price. I know that here in Sweden this would have probably been more expensive, yes. So with that out of the way, first of all, I haven't used it. I just unpacked it from its non-retail packaging, and well, basically I just made sure it works. So let's have a look at that. I will turn off the lighting here. And if I cover this up with my hand, yeah, we see sort of a flaming thing. I can see that the camera does not really pick up the orangey color. It's much more deep orange. So let me try to lower the... Yeah, this is much more, at least on my phone screen, it looks now like a lot more like for my eyes. It's pretty nice actually. I mean, yeah, why not? And it also has a different mode. There is a mode button. I press this once, and let's see here. This time, yeah, it's about this color. So this time it's just a stationary light. It doesn't flicker. Also very nice, but I like the flickering. It resembles more sort of a flame, like this would be a candle or something. When you walk past it from some distance, perhaps, then it probably looks more like a candle. And then of course, if you press the button again, it's turned off. And that's pretty much it. So let me bring this back, the lighting. Yeah, let's measure this. First of all, let's measure the most important thing, and that is of course the solar panel. As we all know, that is the part, that and the battery is what makes up the cost of this item. So this is not in focus, first of all. This is, let's see here, 8 centimeters, and if I turn it around, by 8 centimeters. So I suppose that's 64 square centimeters of solar panel. We also have inches on this AliExpress tape measure, so let's have a look at that. It's about 3.5 inches almost. No, sorry, it's not. It's 3.25 inches by 3.25 inches. And the height is about 18 centimeters, and the width at the bottom, where is the widest, is about 12 centimeters. Here you have inches for those interested. About 4 3/4 inches. Oh yeah, and the 18 centimeters here would be about 7 inches. Okay, very nice indeed. So yeah, but let me take this actually into my bathroom, I think, where it's completely dark and we can see what it looks like in there. Alright, so I have placed it on top of my washing machine here, and we're in my bathroom basically. So let me turn it on into the first mode. There is the button here, which should make it flicker. Okay, I will turn it around a bit and I will turn off the lights. Yeah, sure enough, it did come on. And yeah, it's not bad actually. Very orangey and warm light, and really cozy. Yeah, not bad actually, not bad. Let me turn it into the second position by clicking the button. So now it stays lit, and yeah, it gives some light actually, but it's very orangey, and so maybe it's not a reading light, you know, but that's not the intended use of it either. So that's all nice. Okay, so flipping the switch again, and we go completely dark. Let's head back to the lab, or my project room, maybe I should call it. So yeah, let's head back. And we're back. So now that we have seen how it works, it's very simple. How do we get about to make a teardown of this one? Oh, okay, I see. I just pulled a bit. So we have a couple of latches here on this side, and this all comes out. So the plastic shell comes out, and yeah, we have 2 latches here, no latches there, and a couple of latches there and no latches there. Okay, this sits pretty snugly, so it's not going, we can't unscrew that. Here we have the large mode button. Oh, we actually have some ROHS and CE stuff, and yeah, fancy. And let's try to, I mean, we have 4 screws here, so let's open it up and have a look inside and see what they're hiding from us. Especially I'm interested in the lithium cell. Yeah, I just have to find my screwdriver, so hang on a moment. Okay, I have a little screwdriver kit here, and we shall check. Will this fit? Oh, yeah, I think it will work. So, let's try to do this thing. Oh, they're very tightly fastened. Let me increase the light output here a little bit. I will try to... Yeah, I got the first one. We can reposition ourselves. So we have the first screw there. Oops, sorry. I have to press quite hard for these screws not to strip. So, but it's not too horrible. So we have a claimed 2200 milliamp hour battery cell inside. This just opens up. Oh, yeah. Have a look at that. Okay, it's actually not bad. I mean, we have an 18650 here. And with some protective material at the poles, and it's well, we have a bit of exposed connector there. Let me zoom in. Yes, but it's not too bad. I don't think it would get into contact with anything. Okay, and then yeah, we have just some papery stuff here, just for short circuit protection, I suppose. But the nice thing is that we have a connector for the battery. We could attach pretty much anything, any cell. So this cell should be easily replaceable. I don't know if this is lithium LiFePO4 lithium phosphate cell or not. Okay. And then we got the LED strip there, pointing in two directions actually. So we have two-sided board there with quite a few LED chips. And we also have a dedicated slot here for the cell itself. But yeah, I mean, by letting it fully charge and then seeing what the voltage is like, we would be able to find out what kind of chemistry we have in this one, and then you can of course buy a new cell. So yeah, we have a connector at least, and also to the solar panel we have a connector, which is nice because you could always do something with that. And here we have some kind of rubbery gasket seal from the solar panel itself. Yeah, not bad actually. And everything is screwed into place, so we could easily mount this in some other project if we would like to. But it's very simple in that regard to maintain. I just wonder what the chemistry of this battery is like. Would like to charge it fully and then yeah, we also have some board model number here, and it seems to be from May 5th of 22. And we have the solar panel and battery connector there. Yeah, it would be nice to do some kind of measurement on this and see what kind of volts and amps we get. Yeah, let me bring in my ammeter. So now I'm inside and I have just turned on some light, some studio lighting, and let's see if that oh, I left it on, it seems. So yeah, I'm not getting any display. I need to change battery, so bear with me. Alright, let's see if this works any better. Yeah, display output. Alright, so volts then. DC. So if we measure here on the terminals from the solar panel, we can see that some light is hitting the panel over here at the right. This is not a sunlight, but let's start with that. And I'm trying to match the colors, but I can do it on the board here. Maybe. Okay, this is not the easiest that I've done lately. .215 volts we're getting from the solar panel. Let's measure the voltage across the cell in a similar fashion. .6. Oh. There. 3.628. 3.63 volts. Okay, fair enough. Let's see what kind of if we put this onto amps, can we actually get a reading from this? I will put this over the what else? Let's see here. Yeah, when I turn it to the light, 40 milliamps, 50 milliamps. Alright, maybe I can simulate this sun a bit better. Oh, there we got a better one. 480, 500 milliamps, half an amp. Now I've got a better angle. And just to see that it works, if I close off the light, no. Okay, so this is a is this misreading? Oh no. Yeah, it was negative. So it was too dark maybe previously. So let's oh sorry. Oh no. Maybe this isn't all too accurate. Okay, so let's turn it upside down, then we should have no and have a look. Yeah, now it's zeroed out at least, and I will now lift it. Yeah, I'm getting something at least. But is that something with some accuracy, or is that just rubbish values? So let me try to use some like this flashlight and blast this with some light. I'm not sure that I see a huge difference. Am I doing something wrong? Okay, let's actually connect this across this, or yeah, looping it through the cell here. So we're getting Oh, let's see here. 100 milliamps to the cell, it seems. Yeah. And let me try this. Increasing the output power. Okay, let's try in some actual sunlight, if I can find it. Outside, so let's have a measure of the amps for the flowing from the solar cell. So trying to get this into the sunlight and having a look here. Yeah, 160, 170 milliamps. And let's now put this on the cell instead. So having put this on the cell instead, getting this into the sunlight, we're getting not much. I wonder if 10 to 30 milliamps. I wonder if this cell is a LiFePO4. In that case, maybe it's fully charged at 3.7 volts then. That could be the case. Alright, so I'm back inside, and my current theory is that this is in fact a LiFePO4 cell, which should be at 3.2 volts, I think, right? And nominal voltage, and then fully charged at about 3.7, whilst the other usual lithium cells have a nominal voltage of 3.7 or 3.8 volts and are fully charged and should be cut off at maximum 4.2 volts. So that's my theory, that the strange values that we have seen while measuring with the ammeter, it seems like some circuitry here is cutting off charge to this cell, and it was at 3.7 volts if I'm not mistaken. So yeah, we can of course double check it, but yeah, I think that I will place the battery like this, and we shall maybe see what kind of a current draw we get from this when it's turned on and using the light. So we'll try to lower the voltage basically of this cell and use it up for a bit. But first of all, just to do a check on how much current it draws. So yeah, let's put this to amps. And clamp it here. So currently I think this is just showing some measuring error, but we'll try to see once I turn the button on here. We're using some current, but I don't see any significant change here. Okay, so let's go to the always on mode. Maybe I should. Yeah. So this is upside down now, but okay, let me unclamp this just to see the difference. Let's see here. 0.2 amps. And 0.26 amps. Could that be? Is it picking up something else? Maybe. Yeah, let's measure the voltage across the cell here. Just trying to, yeah, maybe like this, just to get a fresh measurement. I shall plug this in, go for volts, and let's see if we can yeah, 3.67 volts. So if this is a Li-Fi PO4 cell, then maybe it's pretty much fully charged. So why don't we let this discharge for a bit and see what the voltage ends up at of this cell. So yeah, yeah, let's go ahead and do that, and we will see what we can reevaluate the sort of we can reevaluate the solar panel, what kind of charge it gives, and because maybe it's cutting off because this is pretty much fully charged, which is why we saw some odd numbers from the solar cell previously. So I will turn it on, and I will start my timer as well, and we'll see what kind of run times we get. Right, so I have the Thermo Pro timer here, which will set to counting time up. And if you're interested in this timer and why I chose it, for a lot of reasons, do check out the review of the Thermo Pro timer on my channel. It should be easy to find if you search Thermo Pro on my channel. So let's turn. I have to find the button. Yep. And we will start counting. Let's see here. I will actually go to the always on mode. We'll let it run for a while, and we'll see what the voltage will be of the cell in a while. Okay, so almost an hour of runtime has passed, and it's still lighting up nicely. I shall turn off the ceiling lights here, and you can have a close look. Yeah, so it's hard to adjust it so that it looks like it looks to me, to my eyes, but okay. It's a very orangey glow. So let's try to poke around carefully, and we'll set this to volts and see what the battery cell voltage is at now while it's running after an hour. So I shall try to poke around without shorting too much stuff. Yeah, 3.3 volts. Okay, so we have dropped the voltage a bit to 3.3 volts. So we're still above the nominal 3.2 volts of a standard LiFi PO4 cell. Yeah, so an hour at least for now, so let's keep running. Okay, so we're almost 2 hours in on the test, and yeah, the LEDs are still lit, which is a good thing. So let's check the battery cell voltage once again, hopefully without too many short circuits. So oh, my hand is in the way, isn't it? Okay. Yes. 2.77 volts. 2.772. 2.772. Yes. So considering that we haven't seen any cutoff yet, usually a normal lithium cell would usually have to be cut off at around 2.9 volts as the lower discharge limit. But here we have this indeed seems to be a LiFi PO4 cell, and it's at 2.78 volts, which is below 2.9, and LiFi PO4 cells should be cut off at about 2.5 volts for discharge cutoff voltage. So yeah, hopefully it will cut off at 2.5. However, I wonder if this is really what did the specifications say? Let's bring in the paper here. Yeah, built-in 2200 milliamp hour high capacity battery. But maybe my measurement was a bit off on the power draw. Alright, 2 hours 45 minutes into the test, and well, the light is noticeably dimmer. And yeah, I suspect that it will cut off soon. My theory is that the voltage here is involved here are quite low, so trying to use this and clamping the leads on like 2 or 3 volts worth of yeah, 2 or 3 volts. I think it's this isn't picking it up sufficiently precisely. Maybe the electric field isn't strong enough to get from the low voltage. But at least we can measure the voltage itself. I would need to. I suspect I would need to use a normal voltmeter to measure the voltage. The amps in line. Maybe if I can get hold of this type of connector, like a female end to a male end, and then I can connect the ammeter and measure the flow of current in line, so to speak, instead of inductively. Okay, but let's try to measure the cell voltage right now, and we will probe about here, hopefully without shorting the cell itself out. Yes, 2.658 volts. So only 160 millivolts above LiFePO4 cutoff. So yeah, we're getting there, but we should also remember that this is with the LEDs lit all the way, like constant operation mode, instead of the flame. The flame, I think, should be, well, it should conserve more power of the cell if not all LEDs are lit at the same time. I don't think that the controller current or power draw should be a lot higher just because it's in flame mode. But I will try to get hold of such a connector maybe. First, just before I disconnect and start playing about, I do want to allow for this to actually cut off or see what happens at around 2.5 volts and what kind of running time we get. But I think we pretty much get the idea that in the continuous lighting mode, maybe we can't expect a whole night's worth of light. This was at 3.7 volts when we started. However, I'm not sure if it was fully charged or not, because I was relying a bit too much on this clamp method of measuring the current. I will have to try to find a connector set of this type. Yeah. Right, but first things first, so we will let this allow it to run until it's no longer wanting to run, and or when we reach 2.5 volts, and hopefully see if we get a cutoff or not. So yeah, let's keep going for now. Okay, so just above 4 hours have passed, and yeah, the LEDs are just barely lit. But I suppose that in a completely dark environment, when it's dark outside during the night, it should be visible, I suppose. But the voltage of the cell can't be very high right now, so I think that it's time for a new measurement. Let's attempt that. Yeah, 2.57 volts. So we're nearing the lower bound cutoff discharge voltage for the LiFePO4 cells. So let's see if it cuts off. Right, 6.5 hours in, and yeah, it's still clearly turned on, but it's only every second LED that it's lit. So as you can see here in the constant on mode, but it's very dim now. So let's do a new measurement. .53 volts. Yes, very close to what I hope will be the cutoff point, so that this cell doesn't go below the sort of safe minimum cutoff value. Alright, but let's keep going for now. Alright, so 8 hours and 45 minutes almost, and I must say it hasn't cut off yet. I lifted the solar cell. I thought for a second that it cut off, but no, it hasn't. It's very, very dim, but it actually hasn't cut off yet. So let's measure once again the voltage. Yeah, 2.515. So it's right about at 2.5 volts. It hasn't cut off yet, but it does have a few millivolts left of headroom. So yeah, but it's very, very dim. Let's actually check how dim it is in a completely dark room. So hang on. Alright, so we are in my bathroom, and well, being as dim as it is, it's pretty much completely dark here. Yeah, this more resembles the light output in a better way. It's very, very dim, but it still lights up. And let's see what the flame version looks like. Okay, this is showing up a lot brighter on camera. So let me see if I can no, it doesn't want to allow me to change the exposure. Okay, it is a lot dimmer than it looks on camera, but it still is visible, of course. And that's 8 hours and 45 minutes in, if it's completely dark. if there is a little bit of light, then it probably wouldn't be visible at all. So let me open a door to my bathroom and allow for a little bit more light ingress. Yeah, it's still working, but it is a lot dimmer to my eyes than to the camera, so remove something like 45-50% of the luminosity seen on camera. Alright, but let's keep going. Well, as you can see, over 13.5 hours have passed. And yeah, the LEDs are barely lit. They're very dim. And still no cutoff. So let's check what kind of cell voltage we have. Yes, 2.48 volts. So that's a fair bit under 2.5 volt cutoff for LiFePO 4. I suppose that unless you live very far up north or south, like in the around the polar circle, or I suppose you should get some kind of daylight, I suppose, sooner or later within a 24-hour period or time span. And well, in that case, I suppose it just barely gets down to 2.5 volts within 12 hours or so, and hopefully within 12 hours, a 12-hour interval, they hope that there will be enough daylight at least for this to turn off. So even in this room right now, which isn't very bright, we can see that it turns off the LEDs at least. If I just lift the solar panel a bit away from the surface here, so it doesn't need a lot of light maybe to just stop discharging at least, and maybe it will provide 1 milliamp or half a milliamp, I don't know, even in very dusky conditions, which is enough to just make sure this doesn't go below 2.5 volts. But at the same time, we do have a circuit board with some chip on it and stuff, I think, and they could have you know, done something else, like providing a cutoff. But what I do like about this light is it's very serviceable. I mean, you have a lot of space here for, okay, fine, this has a pretty fine spot here for the cell, but of course you could perhaps accommodate a thicker cell than this, maybe a 21700, or I don't know. Either way, you could fit a larger cell here, I suppose. But it's very modular. We have GST connectors here, so we could easily swap out cells or buy a cell with pre-spot welded leads attached. and in case it doesn't already have a JST connector, we could always just buy a kit of such connectors and hook it up. And the same goes with for the solar panel. And in case you want to use the solar panel for some other project, of course, some battery powered project, then with the LiFePO 4 battery, then sure, you can take this this circuit board and allow it to charge from the solar cell, and then you have some kind of output there. You can replace this LED strip with your own in some fancy project with some lighting or whatever. But I think this is a pretty decent looking light, and everything is like screwed in place. It's easy to take apart, very serviceable, and very friendly to modification in that sense. But since we have passed below 2.5 volts, I don't know exactly at which point in time it did that, but let's call it between 11 and 12 hours from what seemed to be a full charge at 3.7 volts. So I think that the next thing we should do here is, since I failed using the clamp to accurately measure any flow of current into the cell from the solar panel, then I will have to get hold of some other types of clamps, and maybe we can use a real multimeter to hook it up in line here with the cell, for instance, and see what the current flow is like. So yeah, but unfortunately I couldn't find any alligator clamps or clips or crocodile clips, whatever they're called. So I'll have to go and acquire such things. So I'll be right back, and we will try to get some measurements done here, and then we'll let it sit in the sun maybe after a while and see what kind of cell voltage we get after a certain amount of time and stuff like that. So yeah, stay right where you are, because this is where the interesting bit will start, I think. So yeah, let's call it the day for this part one in the exploration of this 12 or so US dollars equivalent solar lantern. And in part two, which you do not want to miss, we will actually get into all the nitty-gritty details. We'll do for sure some soldering, and we'll try to perform some more accurate measurements on the current draw and charging current from the solar cell, and see actually what we have in front of us, what kind of a device it is. So far we know that it isn't perfect, like we didn't see any cutoff, and maybe we'll find a solution to that in the next part. But yeah, I think this is it. This is it for the part one review and teardown. And I have already mentioned some aspects and opinions of mine regarding this lantern. But in the second part, we will apart from do some deeper investigation, do some soldering tips and tricks. Um, yeah, don't miss that one. It will be uploaded in not a too distant future, and then we will wrap it all up and basically, yeah, find out if it's a device worth buying and what you can expect from it. Um, so yeah, thank you everyone so much for watching. This about just about an hour long video. I hope you have enjoyed it, and be sure not to miss next part, because then I will do some funny soldering and stuff. So look forward to that. For now, I wish you all a happy day, and see you in the next part. Bye bye.